So what really comes after the smartphone? Today we're diving into Meta's massive, multi-billion-dollar bet on the answer, and it's a journey that really has two major stops, a device that's here right now and a pretty radical vision for our future.
I mean, think about it. For over a decade, the smartphone has been at the center of everything, right? But the biggest question in tech is, what's next? Meta is betting the answer is to move technology from the palm of our hands to our faces and our wrists. But as you're about to see, they are taking two very, very different paths to get there.
And here they are. On the left, you've got the Ray-Ban Meta smart glasses. Think of it as an evolution of tech we already know. But on the right, that's the experimental Neural Band. And that's a potential revolution in how we interact with machines. Together, these two devices map out Meta's entire game plan, from now to what's next.
Okay, first, let's start with the present. This is the second-generation Ray-Ban Meta smart glass. And its most important feature might be what it's missing, a display. Yeah, this isn't about slapping a screen in front of your eyes, it's about weaving digital tools into your life without pulling you out of it.
So its first big trick is to basically rescue the camera from your phone. Tucked away right in the frame is a 12-megapixel camera that lets you snap photos and record video from your own point of view, completely hands-free. You literally just see something cool and you can capture it.
And the second big move is putting the AI assistant right in your ear. Now, because the AI can see what you see, it becomes multimodal, which is just a fancy way of saying it understands both your words and your world. You can look at a landmark and ask what it is, translate a menu in real time. It's like having a context-aware AI for the real world.
But get this. Think about all the tech they had to cram inside. A camera, 5 microphones, speakers, a processor, and the total weight? Just 48 grams. That's almost exactly the same as a standard pair of Ray-Bans. So how on earth did they pull that off? Well, the answer is just some seriously clever engineering. They used a technique called System in Package, or SIP, which is kind of like building a tiny skyscraper of computer chips to stack them in a super small space. And to deal with the heat, the entire frame actually works as a heat sink, spreading the warmth out so they stay comfortable to wear. Okay, but here's where we hit a wall. These glasses are awesome for capturing content and asking questions. But for true augmented reality, with digital stuff laid over the real world, you need a better way to control it. Constantly lifting your hand to tap and swipe gets really tiring fast. Developers even have a name for it, the gorilla arm problem. And Meta's solution for that is something else entirely.
And that brings us to the future. If the smart glasses are an incremental step forward, this next device is a giant leap. It's Meta's radical answer to that gorilla arm problem, and it's called the Neural Band.
Now, just to be super clear, this wristband isn't for the Ray-Bans you can buy today. It's a prototype controller designed for future AR glasses that have full-blown displays. And its whole purpose is to let you control those glasses not with your voice, not with your hands, but with the signals coming directly from your brain.
So how in the world can a wristband read your mind? It sounds like something straight out of a movie, right? But the science behind it is very real. It's based on a technology called electromyography, or EMG for short.
Here's the magic behind it. When you just decide to move a finger, your brain sends a little electrical signal down the nerves in your arm. Now, the crazy part is that the EMG sensors on this wristband can detect that signal before your finger even moves. It's not reading the motion, it's reading the intention to move. And that lets you control things with tiny, almost invisible microgestures. To put it simply, EMG is basically eavesdropping on the conversation happening between your brain and your muscles. It's tapping right into your nervous system to translate your intent directly into a digital command. So a tiny twitch of your index finger could become a click. A subtle rub of your thumb and forefinger could become a scroll. Now, of course, this is ridiculously hard to do. It really demands two huge breakthroughs. First, you need sensors that are so sensitive they can pick up those faint electrical whispers through your skin without any interference. And second, you need a powerful AI chip right there on the device that can interpret all that neural data and turn it into a command in less than a millisecond.
So this is the really important part to grasp, just how fundamentally different these two devices are. One is really an extension of something we already have, while the other is aiming to be a complete replacement for a core part of it.
You see, the Ray-Ban Meta is a product you can buy today. It's an input/output device that uses a camera and voice commands. But the Neural Band, that's a future input technology. Its whole world is EMG sensors and machine learning, designed to read your neural signals.
And this quote just absolutely nails the difference.
The Ray-Ban glasses move parts of your smartphone, the camera, the speaker, to a more convenient spot on your face. But the Neural Band? That's a direct shot at replacing the touchscreen, the main way we've interacted with tech for 15 years, with our own nervous system.
The potential here is just staggering. I mean, imagine controlling a prosthetic limb with the same intuitive thought as a real one, or a surgeon performing remote surgery with these tiny micro-gestures. But it also leads to a pretty profound question. As we move from controlling devices by tapping on glass to controlling them with our intentions, where exactly does the technology end? And where do we begin?